Okay, so question 5 here, we're starting off splitting it into partial fractions. So the form, if I've got two distinct brackets on the bottom here, is a over 3 plus x and b over 1 minus x. And I've multiplied through by this to cancel all the denominators. So here everything cancelled, I was left with 1. Here the 3 plus x cancelled, and here the 1 minus x was cancelled. And I'm going to find a and b by substituting in sneaky values of x to try and make this easier. So the first thing I'm going to substitute is x equals 1 to make this bracket 0. Then I get 1 equals a lots of 0, which is 0, plus b times 4, so b is a quarter. I'm also going to do x is minus 3 to clear this bracket, so I would have 1 equals a lots of 1 minus 3, so that's a lots of 4 plus 0, so a is a quarter as well. So let's rewrite the answer then. F of x equals 1. I'm going to put, instead of writing a quarter at the top, I'm going to put the 4 straight on the bottom. So, onwards, let's do part B, and we're looking at doing the binomial expansion. So I'm going to do each of these bits in turn. So I'm starting off with a quarter of 3 plus x to the minus 1. Again, I want a 1 at the beginning here, so I could write that as a quarter of 3 lots of, and then 1 plus x over 3 to make the 1 at the front. That's all to the power minus 1. So using our index laws, that's 3 to the minus 1 multiplied by 1 plus x over 3 to the minus 1. So 3 to the minus 1 is a third, so that's a 12th. And I've got 1 plus x over 3 to the minus 1. So let's actually start expanding that then. So I've got 1/12 of, in the answer I'm only going to the x squared term, so I'm going to do that. So I've got 1/12 of 1 plus n times x, so that's minus 1 multiplied by x over 3, plus n minus 1, so that's minus 2, x squared over 2 factorial, and let's work out what that is. Sorry, excuse me. Okay, let's do the other one then. So that was this first bit. Let's do the second bit. So I'm going to have a quarter of 1 minus x to the minus 1. In this case, there's just a 1 out front, so that's nice and easy. So that's going to be a quarter of 1 plus n times x plus n minus 1 x squared over 2 factorial. So again, more tidying up, make sure you square this minus here, otherwise you're going to have some problems. So that's quarter lots of 1 plus x squared. Okay, so looking at the original f of x, you'll see that these two bits are added together. So I need to add these two together. What I'm going to do is multiply top and bottom of this by 3, just so I've got a common denominator of a 12th of everything. So that would be a 12th of 3 plus 3x squared. So, adding them together. So I'd have a 12th of everything. So I've got 1 minus x over 3 plus x squared over 9 plus 3 plus 3x plus 3x squared, which is a 12th. 1 plus 3 is 4. 3 is 9/3. Take away 1/3 is 8/3. I've also got this x squared term is over 9, so that would be the same as 27 over 9. If I add this one on, I get 28 over 9. And then let's just multiply through the 12s and cancel down, and we get what we're supposed to, so we get a third plus 2x over 9 and plus 7/27 x squared, as we want. Looking at the last part, we want to know what range it's valid for, and whether or not it's valid for 2.5. So if we have a look at what we used here, this one, we substituted in x as x over 3. So that means x over 3 has got to be less than 1. So x modulus of x has got to be less than 3. So 2.5 is fine for that one. Let's look at this one. We substituted in x as just minus x. Modulus of a minus is still plus. So here x has to be less than 1. So for it to work for the whole entire expression together, x has got to be less than 1. So 2.5 isn't valid, and you just need to explain that.